Thank you. Hey everybody, my name is John. Thanks for coming out to hear an Elixir talk at our Ruby meetup. There's a couple reasons why I wanted to give this talk, and the first one is I think there are some problems that Elixir is really great at solving, but also because I think this is just really cool technology. It kind of reminds me of when I first saw Rails and I was doing .NET, and I just thought, why is everybody not using this? Like, this is so much better. This is so much nicer, and it brings a lot of things to the table that we haven't had before. And so the structure here, I want to talk very briefly, just kind of what is Elixir, what kind of problems does it solve, and then spend the majority of our time looking at a very low level, how does Elixir do what it does, and then kind of what the effect of that is when you pull back up to a higher level. And before we start, I just want to say we still like Ruby. Ruby is great. It does a lot of things really well, but it's not perfect, and I think there's some things that we can learn from Elixir and use for specific types of problems. So we'll start with what Elixir is. And Elixir is a functional language created by José Valim, and it's built on top of, and it compiles down to Erlang, and it runs on the Erlang VM, which is called the Beam. It's concurrent by default, and like many other functional languages, data is immutable. Now, OTP is the Open Telecom Platform, and this is... I can hold it if I need to. Testing, we good? Okay, so OTP, the Open Telecom Platform. And this is basically a bunch of Erlang code that talks about and describes how these servers or nodes can communicate with each other. It's a technology that's been around for a long time, probably almost about 30 years, originally designed for phone networks, where it kind of gets its name. But it's stable, it's battle-hardened, it's been used for a long time, and Elixir really gets to leverage all of this really old, great technology. So if we look at what kind of problems would we want to use Elixir for? I'm not advocating in this talk that we just immediately go rewrite everything we have in Ruby and Elixir, but that there are some great things that Elixir does that we can take advantage of. And so if we look at kind of some Erlang use in the wild, and this is just something I stole from Stack Overflow, we can kind of see a trend here in the problems that Elixir and Erlang specifically is solving. And so you've got a lot of things where there's a lot of connections happening, things that involve a lot of background processing. There's still the kind of the phone network type stuff that's hanging around. But really, if we kind of group these problems into a couple things, in my opinion, it's if you have issues with performance or scaling, if you have multi-part systems that need to communicate with each other, or if you have systems that are kind of continuously running in the background, churning and doing a lot of processing. My mind goes to stuff like machine learning or a lot of live streaming type of stuff. And then this fourth one is one that I added that I don't think you'll see advertised on the Elixir website, but I think it really helps us architect our software systems better. Okay, so how does it solve these problems? At a very high level, it gives incredible performance. They're fault-tolerant systems, and it really helps us to kind of separate our domain models within each other and kind of define the boundaries of what these things should do. And so now let's dive a little deeper and let's talk at more a code level. And at the core of Elixir are processes. And these processes are not what you would typically think of as like an OS level or your Rails server that has threads or processes. These are lightweight VM processes. It's not unlikely or not unheard of to have hundreds of thousands of these running. They're isolated, they run concurrently, and when a process dies, you can reclaim its memory. And so let's look at kind of how we make processes, how we talk to them, how we interact with them, stuff like that. So the first thing, if we want to spawn a process, we have a function for it. It's called spawn. And in this example, we're just passing it an anonymous function, and we're printing out the value of 1 + 1. So we see 2 is printed out. And then below that, we see the process ID, or the PID. There's a lot of PID passing, so you can talk to specific servers, and you'll see that a lot. So once we've spawned a process, if we check and see if this process is alive, we'll see that it's not. And that's because it ran its thing, and it died, and it's gone. And while this can be great for a couple things, it's obviously not very useful if you want to have this living system that can talk to each other. So how do we talk to a process? Processes can be communicated with their mailbox system. So you send a process a message, it reads the message out of its mailbox, and if it knows how to do something with that message, it'll go do whatever work it's supposed to do. Now, the IEX shell, which is kind of like Rails console, is itself a process. And so if we call self, it'll return its process ID, and then if we say, is it alive, of course, it's alive because we're working and using with it. Now, because this is a process, we can actually send messages to our IEX terminal shell. And we do that with the send and receive keywords or functions. And so we can say send, and then we pass the process ID, which is our shell, and then we can send it this message. And the message in this example is a tuple, which you may or may not be familiar with. It's basically just an ordered collection of elements. It can be whatever you want. Here we're sending the atom hello, which is very similar to a symbol in Ruby, and the string world. And we can see that it just prints out for us, hey, you sent this hello world tuple. Now to interact with this, we set up a receive block. And receive is a blocking function that a process waits for a message to come in. And so if we set up a receive block like this, we're doing some pattern matching here, which is something if you're not doing Elixir, you probably are not familiar with. It's kind of like a fancy case statement, but like much more powerful. And so you're not just checking, are these things Boolean equal, but also does the structure match? Do you have, we can see, we're saying, is the first thing a tuple with the atom hello, and then we can also destructure a variable out of that. So we can say, whatever the second thing is, I don't care what it is, put it in this variable message and give it to me when you're inside of that specific statement. And the second one there, if we are going to pass hello, we're just going to print out won't match. And so we see at the very bottom, we passed hello in the string world, so we just see our message printed out back to us. So this is a little better. We're talking to the process, it's sending stuff back, but it's still not super exciting. And so the next step here is to make a process that will kind of run on its own that we can talk to and continually send it messages. And so to do that, we'll just make a new Elixir project using the mix tool, which is similar to Rails or Rake. And then we'll start it up in our console using IEX. Now, this implementation for a process is kind of naive, but it really illustrates what's going on here. And that is, processes at its core are really just sending and receiving messages. And there's some other stuff, but that's the core of what a process is and how you interact with it. And so in this example, we have a start function. We're going to use our same spawn, but instead of printing something out and dying, we're going to call this loop method. And this loop is a private function where we receive a message, and then we call loop again. And then we receive and we call loop, and we do that over and over in a recursive fashion. Now, if you see that in Ruby, that might be a little scary because recursive functions, like, or you might be thinking, okay, we're going to get Stack Overflow because we're just going to go until we have nothing left. But there's some Elixir, or Erlang and Elixir magic that actually optimizes this to kind of just wait, so you don't just spin your stack up to max capacity. So if we try this out, we'll call our start method and save our PID. And then next we'll send a message to that process. We'll send the tuple hello in OKCRB, and we see it prints it out. And then if we send the other message, world, it says no message for you. Now, this is the part where it's kind of like in math class where you learned how to do logarithms by hand, and then they say, okay, take out your calculator and just forget all that stuff. Because you know how it works, but we're just going to use our calculator. And so this is really what OTP is great for. OTP is this abstraction around this message processing, and it adds in a lot of stuff we didn't have in our default implementation. So we didn't have things like timeouts. We didn't have things like processes dying and communicating with each other in that way. And so there are a couple OTP abstractions. There are many of them. This is just a few. We're going to look at GenServer specifically because I think it's a great example of how we work with this message processing system. And so there are some things like agent and task, which are just simpler than GenServer, so it's easy to understand those. And there's some that are a little more complicated, but still just use this basic GenServer type mechanism. And so GenServer stands for generic server. And from the hex docs, hex being the Elixir package manager, it says the goal of a GenServer is to abstract the receive loop for developers, automatically handle system messages, support code change, synchronous calls, and more. So it's giving you a nice wrapper to do all these things without having to worry about so many of these edge cases. Okay, so if we're going to make a GenServer, there's basically three different parts. at the top, we're going to say use GenServer. And this is an Elixir macro that basically, before it compiles this file, it spits all the GenServer code into this file and compiles it. It's kind of like require in Ruby. And the second thing is we're going to have our client functions. And this is the part that we design that is our public API. And so this is, how do I want to interact with this GenServer? So if we're going to make a tweet fetcher, we might have a method called fetch tweets. The last kind of core part is the server callbacks. And this is where you would handle the messages that are sent to your GenServer. And so looking at the client a little bit, let's say we have a fetch tweets method. And inside of this, what we need to do is send a message to our server of fetch tweets. And there's two ways you can send messages, and that is through a call or a cast. And a call is a synchronous function, so you're waiting for a response. A cast is just something where you send, you don't really care about the response. You can kind of think of the idea of if you called someone up on the phone, you would wait for them to answer and get a response. Whereas if you're just casting something away, you don't care. You're just saying, hey, here's a message, do whatever you want. So to do this, we would say GenServer call, give it our process ID, and then pass it whatever message we want to do. And so in this example, it's fetch tweets, and maybe we pass some user ID to tell it to go get the tweets for it. You could also do this as a cast. Now, to receive these messages, switching over to kind of the server side and the callbacks, there's two callbacks you need to implement, and that's handle call and handle cast. The first argument here is the message that you're sending it. You see that we're also sending the state, so when this callback is hit, it sends the current state of the process. And if for a call, you can see who it's coming from, because maybe you care about that. For a cast, it's asynchronous, so you don't care. And there's a couple things we can return from these. At the top we have, if we're handling a call, we can say reply. So here's the part where we say, like, you requested this, now here's the data you asked for. You can also say no reply in a call, which is probably not a everyday use case, but it's more like, I don't know the answer yet, I'll get it back to you later. And then you can also say you're stopping for whatever reason. Handling a cast is the same way. There's no reply because it's asynchronous, so you just say, okay, cool, I'm not going to send anything back, or I'm stopping. There's one more that is just worth mentioning. It's called handle info, and this is basically everything else that the system sends to your process. So if you're doing a call or a cast, you're specifically saying, I've set up this message to do this thing. Handle info is kind of everything else, so if like a process goes down, the system itself will send messages through this. So now if we put this together, we've got our client, which we have a fetch tweets method, and we're going to do that as a cast because we're just going to say, go fetch the tweets, I'll check back in later. And then a tweets method to actually get those tweets back, and that's a call because we actually want to get a response back from that. If we switch over to the callback side, we have handle cast. We could do that similar pattern matching that we saw in the first example, but since we only have one cast function, we're just going to look specifically for fetch tweets. And then we're going to reply, no reply, because it's a cast. And that second element there is just a fast list syntax for just appending a new item to a list. So the current state is going to be an empty list, and we're just, every time we say fetch tweets, we're just going to put the string new tweets at the beginning of the list. And for a call, we're just going to reply with the state, which is our list of tweets. And then the last parameter, we're just going to send state again. So at the end of these callbacks, the last parameter is the state you want to basically like spin forward. So like, I changed it, and now our state's here, and here's where we're going from there. And so since we're not doing anything when we return tweets, we're just going to say keep the same state. So if we try this out, we can call GenServer start link, which we'll talk about links in a second, pass it the module, and the empty list is our initial state. And then if we say fetch the tweets, we don't get anything back. IEX is just printing OK here. And if we fetch the tweets, we get our first element, a new tweet in a list. And then if we fetch tweets again, we'll see that we have another tweet appended. Okay, so that's kind of how processes work at a low level. So now, if we pull back up a little bit and kind of see, like, what does this give us, and how does this help us? Well, we talked about performance. Here's a quote from the WhatsApp blog. Today we have we've turned some knobs, shifted some traffic around, and achieved 1 million established TCP sessions on a single machine with resources to spare. Later I heard that this number was actually, got up to 2 million, but it handles concurrency really, really well. And then if you're familiar with Phoenix, which is the Rails-esque framework for Elixir, it's not uncommon to see responses returned in microseconds, so less than a millisecond amount of time, which is just crazy fast. And so, I mean, we know this, but compiled concurrent languages are just fast. So now let's shift a little bit onto fault tolerance and how Elixir and Erlang makes these systems that are easily recoverable from errors. And so with fault tolerance, the more you distribute a system, the more cost it comes to maintain it and to work with it, right? So the more complexity you have, the more surface area there is for problems and things to go wrong. And so the Elixir way for handling problems is to just let it crash. So they take the mantra of exceptional circumstances should be exceptional very literally. If you're in a case where you can't do anything about it, crashing it makes sense. It's the right thing to do. And I stole this image from another talk, but this is like literally what you do. You turn it back on and off again. If you think about if you have a problem with your phone or your computer, what do? You restart it, because restarting something with fresh state usually fixes a problem. And as a note, this does not save you from yourself. So you cannot just be a terrible programmer and it's just going to fix all your problems. But it does help you handle these weird edge cases where you're just like, how does that even happen? I don't even know how to make that happen. It's fine. You just restart and you're good to go. So how do we interact with these crashes? We do this with two ways, and that is through links and monitors. Now, a link, like we saw earlier when we said GenServer start link, a link links two processes, like it sounds, and it's bidirectional. So if A is linked to B and B crashes, it will also crash A. And it sends a signal between these processes. Now, this is contrasted by monitors. A process or a link is two-way. A monitor is a one-way. It's more observing a process. And so if A is monitoring B and B crashes, A is fine. But it just receives a message saying, hey, B's down, do whatever you need to do. Now, built on top of these things, in OTP, we have these things called supervisors. And supervisors basically kind of combine this link and monitor behavior where they form this parent-child relationship. And so a parent can supervise a child, and instead of crashing, a supervisor will trap and exit. So it says, my child crashed, now I'm going to perform some type of supervision strategy. And so that could be something like child 1 crashed, restart child 1. Or child 1 crashed, restart all my children. Or it crashed and it's continuing to crash, so maybe I'm going to crash myself and throw it up to my supervisor. And so this builds out this concept of supervision trees. So you kind of have this almost self-healing system where each little piece tries to restart itself, moving up to the bigger chain. And it could crash all the way up to the top, which you have a serious problem if that's happening. But ideally, this would fix issues at the smallest possible level. So to do a supervisor, it's very easy. This is the essentially application RB of a new Phoenix project that I generated. And so you see that there's two children we're starting, something called a repo and something called an endpoint. Repo is like how you talk to the database, and endpoint is just like the beginning of your web routing. So like when the request comes in, it hits the endpoint. And so we make a supervisor and say, hey, supervise these things, and we're giving a strategy of one-to-one, which is just if it crashes, restart it. Now, Erlang has this cool thing called the Erlang Observer, which I will attempt to use sweet mouse practices to get over there. So here I'm looking at just a brand new, like Phoenix.nude, a project, and so I'm looking at the processes that are running. And so if we scroll down, I don't know how to zoom on this, but so here we see we have the supervisor, and this is like one of our rootmost nodes of our app. And so if we come down here, we can see our repo, which we expected. We started a repo and we started an endpoint. And so if you kind of look at these process IDs over here, they're in the 230s or whatever. Let's say we have a problem with this. Oops, that's not what I wanted to hit. So if we say killed this process, you'll notice that it will restart the processes that we just killed. So here you can see these numbers are now in the 900s. So we've kind of talked about how processes work, how do we get fault tolerance, how do we get super performance. So let's kind of let's pull back up from the code level and talk about how does this affect how we develop software systems. And so if you think of a typical Rails app, it might look something like this. Okay, your app is pretty much Rails. Like you've got some things maybe poking around on the sides, but Rails is your app. It's the majestic monolith. Now, I'm going to use a dirty word here, but Elixir apps are made up of microservices. And so an Elixir app structure is different from your Rails app. Elixir apps are a project that contains many apps. So if you have a logger, or you have a Phoenix web framework, these are all little apps. So it's not like Phoenix or Elixir is the core of your thing, and you have these other things hanging on. So you might have some type of hypothetical structure like this. And so maybe you've got a JSON API, maybe you've got a Phoenix project, maybe you've got some type of authentication app that's doing its thing. And so you get this distributed system that is all still kind of running all in one. But it helps you to break down and think about the boundaries and the connections between things, because you can't just say, oh man, I really need up-to-date thing. I'm just going to reach in and like mangle this internal state, because you can't. Because you can only interact through this process message sending. And so you have to define very clearly what your app is supposed to do and where the boundaries and connections between these things are. Now, when I was making this talk, Paul reminded me of a link to an article that James wrote recently. He's talking about a guest on the Elixir Fountain podcast, and the guest made this comment that Elixir is the most object-oriented language, which sounds kind of funny because Elixir is a functional language. But the author's point and James's point as well, which I agree with, is if you really think about what object orientation means, so Ruby has a class called objects, and if we say what thing-oriented programming is, object orientation is really just things sending messages to each other, extracting away state, abstracting away behavior, and it's really just you're passing messages, which at its core is what Elixir is doing. So to wrap it up here, Elixir is the sum of a few very good parts. It's got all the developer happiness, productivity type stuff we like in Ruby and Rails. It's got the power of Erlang and OTP. I personally think it helps you architect your systems better because it forces you to think about the connections and the relationships between things. And there's just cool stuff popping up. I mean, yes, Phoenix is a Rails framework, but I think eventually it'll be more than just controllers and routes. There's also the NERVS project, so if you're into embedded software kind of stuff, I think people will begin to use this technology and produce some really cool stuff out of it. So before we open up to questions, I want to point you to a couple resources. The Elixir docs and the Hex docs are actually really good. Instead of just being like API list, it starts with what does this thing do? Here's a practical example of it. And then even the functions and stuff have really great documentation. There's also Elixir School if you're just starting from ground zero. And I want to point out this book in particular, Elixir in Action, which I saw Matt tweet today is actually 50% off. I really like this book. It essentially kind of, with our little simple process that we made, it starts at the very basics and essentially kind of builds through OTP, so you handle trapping exits and timeouts and all this kind of stuff. And so it's really good to understand like what is actually going on. And then finally, I'll go ahead and plug OKC Elixir. Is Tuesday, May 30th at 8 p.m. This is a Google Hangout, so it's not a physical meetup. If you're watching online, you don't have to be in OKC. And we're covering testing, I think. So check that out. And now I'll open it up for questions. Mr. Roberto.